Hi, I'm Oliver Gao. I'm the director of Cornell System Engineering Program, and I have been doing these system conversations with our invited speakers to our Ezra System Seminar Series. Today, I'm very delighted and honored to be talking to Dr. Oskar Sigvaldason, and who is a PhD and also who is I think Ph.D, which is a certified
professional engineer.
Professional engineering. So Oskar is actually he is a founder and the president of SCMS Global, and he's also a member of Global Energy Scenario Committee, World Energy Council, and a director, which is a former chair, and also Energy Council of Canada, I believe you also served as former president of Acres International.
Right.
Yes, so Oskar, through his wholly owned corporation, which is SCMS Global, he provides consulting and management services, including integrating engineering of infrastructure projects with economic development, environmental sustainability, and strategic and policy management, and also assessments. I do want to point out that Oskar has provided leadership in the application of systems methods and system analysis for decision support, for deriving optimal solutions for complex problems, especially for integrated energy, water resources, infrastructure, economic, and environmental systems. As you can see that this is really systems oriented. So Oskar, it's great to have you here. When I was looking at the work you have been doing, I was just asking myself, how did you do that? How did your career evolve? From like after you graduated with your PhD, and then in the past 30, 40 years, how did you evolve your career and to cover such a broad spectrum of different domains? And maybe I think all of us, we are interested in learning more about yourself and your career.
Okay, well, thank you very much. And thank you for inviting me to participate in your seminar series today. So I've had quite a long career, as you can judge from my bio, but I started basically as a civil engineer, working on civil engineering projects for a company called Acres International back in the 1960s. And then after I was taking courses at University of Buffalo at that stage. I was working out of Niagara Falls, Ontario, and I was very interested in understanding how decisions were made with regard to major infrastructure developments, because as you know, these are big and complex and so on. So I was encouraged then to take a year off, and so I joined the Harvard University Water Resources Group.
That was basically the place.
Yeah, that was the place. Yeah, they had produced their first book on the planning and development of river basin systems. And at that time, Canada had just passed its Rivers Improvement Act, and were very interested in the application of modern systems methodology for looking at river systems in an integrated systems context, rather than just as a series of individual projects. Mm-hmm. And so that early methodological development took place at Harvard, and so I joined that group, spent a year there taking courses at both Harvard and MIT, and that's where I met Pete Laux, because he was also there. And then we had the opportunity to work together on the development of methodology for the Government of Canada. Mm-hmm. And then that led to a series of assignments which was focused at that time on water resources systems. So we had the opportunity of putting together operational plans for some of the river systems in Canada. And this was at a time when the international lending agencies like the World Bank and the Asian Development Bank were beginning to look at their investment programs in water projects around the world. So we then had an opportunity of working in Thailand on the management of the Chao Phraya Mekong river system in Thailand, which covered about 60% of the land area of Thailand. So we put together, over a period of about 7 years, a water management system and helped to create the institutional capacity to be able to manage this process. That was a joint initiative between the Royal Irrigation Authority of Thailand and the Electricity Generating Authority. And that then evolved into another assignment, again with funding from the World Bank, in Sri Lanka for the Mahaweli Development Program, which is a huge multi-basin river basin system. So we had a contract then to look at operational strategies for managing the whole multi-basin complex, and that went on for several years. And then in the early 1980s, we had an opportunity. We were invited by the government of South Africa to put together the water management system for their whole complex of river systems, which eventually included all of the river systems in South Africa. And so that was a project that went on for about 7 years. So that was a kind of the focus on the water resources side, which included planning, development, operational plans, and actual system dispatch. But over that period, I also got involved in energy and electricity supply planning, again with funding from the international lending institutions. So we built up a core capability in the company to be able to prepare national plans, which are both investment plans and strategic plans for mostly electricity supply, but in some cases for energy. So we did this for Pakistan, for Bangladesh, for Sulawesi in Indonesia, for Ethiopia, Kenya, Tanzania, Ghana, and Sudan. Okay, so that was over a period of about 10 years when, through the 1980s, when the banks, international banks, were really interested in making sure that the plans, whatever projects were being applied for by national organizations, that they were consistent with minimum cost planning. Then, subsequent to that, we became involved in actual development models for system dispatch for hydropower production. And that became a niche capability which we applied initially to systems in Canada, but that evolved into systems worldwide. And at this stage, the model that we had developed for the system dispatch is now being used on the Columbia River system, which is the largest integrated hydro system in the world, and managed by the Bonneville Power Administration, and also for the state of California. And so that's became another niche capability. Most recently, my activities have turned to energy and climate change, and so we had this opportunity.
So you kind of shifted from the kind of water resources to energy systems.
That's right.
Of course, the two are very closely connected.
That's right, yeah. And then more recently into combining energy systems with greenhouse gas mitigation, which is tied in with the climate change considerations. So that's kind of a quick summary.
Given, I think, this very diversified international kind of work experience and project portfolio you have had, I think I would like to ask you, like from your point of view, what do you see as the major dominant challenges, system challenges that our society, our world, is facing nowadays?
Well, that's a very interesting question, and it's an aspect that I've given a lot of thought to. It's interesting to note that some governments were moving in the direction of really trying to make sure that government policy and government strategy was related to comprehensive consideration of different departments and different institutions and so on. So in Canada, for example, for a long period of time, we had councils, okay? These were at the federal level that basically were intended to kind of bring together the diversity of considerations from energy, transportation, infrastructure, finance, and so on, to make sure that the decisions that were being taken were based on a very comprehensive consideration of all of the important factors that should be impacting on the decision. Unfortunately, sometimes these things were viewed as being too abstract or getting too much into the political decision process, and many of these councils were subsequently disbanded. Okay, and so what has tended to happen is that when there are decisions being made that span a range of disciplines or a range of sectors, they tend to be made by Treasury Board or by the Minister of Finance, who may not necessarily understand the complexities of infrastructure development and so on. So the challenge, I would say, is really twofold. First of all, is that it has to be appreciated that these kinds of decisions, which bring together an integration of various departments and so on, are very complex. Okay, and it's important that that capability be there. But the other part is that people who are in decision processes like to simplify problems, okay? But in the process of simplifying, they often wind up ignoring the consideration of some of the most important aspects that should be impacting on the decision process. So the ability to be able to plan, to do planning in a comprehensive, rigorous way is really, really valuable, but often not respected. So that's the challenge, I think, is to continue emphasizing the importance of good planning and good, comprehensive, integrated planning.
I think that's definitely very important. You mentioned this integrated, comprehensive planning. So now, if you think back, for example, 20 or 30 years ago, when you worked on some project, that I suspect those project problems were more like engineering problems, very specific engineering problem. But now, later in your career, you're kind of working more at higher level, dealing with the kind of multiple stakeholder problems, and definitely you probably felt that okay, now things are becoming more complicated. So do you think that this complexity of the challenge, is this complexity the same as like 30, 20 years ago, or the complexity itself has evolved to be more complicated?
No, there's no question that today's problems are more complex than they were 30 years ago.
Why?
There are more options that are available to be considered in the decision process. If I can use an example on the electricity supply side, electricity, it was always complicated, but the number of options that you had were basically hydro, nuclear, and thermal projects, and some nominal amount of storage. Now, with the introduction of intermittent renewables like wind and solar and run-of-river hydro and in-stream generation and tidal and so on, this has added complexity that not only needs to be addressed in the context of meeting energy demand, but also dependable capacity demand, but also now, more importantly, the problems of system dispatch, okay? Mm-hmm. Because systems dispatch problems for systems that have a lot of wind and solar are very complicated, and this needs to be taken into account in the planning process. So there's no question that it's a more complex situation, mm-hmm. Also, the greater consideration of social concerns and considerations and the whole decision process, where we're now dealing with the need, the needs for massive transformation, for example, in our energy systems to meet climate change mitigation requirements, and the resistance to change, which is now much more dominant than it was 30 years ago, makes the challenge much more challenging.
Thank you for describing these challenges. And of course, you have been the expert to confront this complexity and this challenge. So what do you view as some important either approaches or philosophy or methods for us to use to confront these complex challenges?
Well, the first thing is to really emphasize the importance of good planning. And there are enough examples around where we're living with the consequences of an absence of comprehensive, rigorous planning. Okay, so people have to understand that we're dealing with a very complex, increasing complexity, and the importance of planning, so you really understand the system, is much more important than it used to be.
So,
Yeah, I was also going to add that it's important. There's a lot of advocacy organizations that take very polarized positions on certain things, such as certain organizations say no more hydro, okay, or no more nuclear, and so on. And for us who are in this business, we have to be very careful that we're not taking advocacy positions. Our role is to make sure that we are presenting the results in a very comprehensive way, using science-based information and doing our best in terms of having people understand the consequences of certain positions in terms of cost and impact and so on. So that's one thing. The second thing I wanted to emphasize is that I think the real benefit from the application of systems methodology is to get people to focus on the broad question of how do we go from here to there, okay? I refer to this as pathways, okay? You talk about, really you have to understand the pathways, and it's not to say you're going to focus on a particular pathway, but you need to now talk about, different pathways and what are the consequences and impacts and costs of different pathways. So you have to find a way of getting key people and key organizations to understand pathways. Okay, if I can use an example, it's if we set a target for 80% reduction in greenhouse gas emissions by 2050, there's many different ways to get there. Okay, each of which has a different combination of cost and impact. So the discussion should really start with the pathway. Okay, then once you have kind of a degree of consensus, then you begin to focus on strategies. Okay. Now the pathway, are you going to go with carbon capture and storage? Are you going to go with a lot of hydro? Are you going to go with nuclear? Are you going to build lots of solar things and so on? Okay. So you have to make some high-level decisions about what is acceptable and what is not acceptable in terms of strategies. Okay. Once you're on strategies, once you've got a picture on strategies, then you begin to address policies. Okay, so you don't start with policies, which is what a lot of mistakes are being made. So it's pathways, strategies, and policies in sequence. That's a hierarchy, and it's very important for people in the systems game to kind of have that kind of philosophic context for how they want to convey the the consequences of different types of solutions to people who matter, or to people who are prepared to listen and understand.
I think this is really a very important, I think, issue, and also a kind like a paradigm shift of thinking, right? So in that case, of course, when we talk about pathways, we're not talking about 4 years or 5 years. We're probably talking about 30 years,
Correct.
50 years,
Right.
right? So in this, do you want to give an example? I think this is definitely the right way to do things. Do you want to give an example of how, like, you, through your work, you help, Canada to come up with a pathway in achieving? Now, you have all this, Paris Agreement, or the COP agreement to reduce greenhouse gas emissions. Do you want to use Canada as an example to illustrate how you apply this pathway, how you derive an optimal pathway, and how you would like to implement it?
So I think a better example is the UK.
Yes.
I prefer to use that example because they're 10 years ahead of Canada. Okay? And so
Great.
that's actually a very good model. But as you know, they passed the Climate Change Act in 2008. They were the first country in the world to pass a Climate Change Act. Okay? And the goal was to achieve 80% reduction in GHG emissions by 2050 relative to 1990. And this was for each of the 6 classes of GHG emissions. Okay, so this was an act of Parliament. Okay, so this was. So the next question now is, so how are you going to deliver on this? Okay, first of all, institutionally, they embodied the responsibility for this act in the Department of Energy and Climate Change. Okay, not environmental, energy and climate change, because it was integrated with energy. And then they created a committee on climate change that worked with Parliament. Okay, and so the Committee on Climate Change has to report to Parliament every year on where they're at and where they're going and what progress they're being made and what are the new targets and so on. So in their case, they decided that they would establish 5-year carbon budgets. Okay, the first carbon budget being for 2010, and then going to 2050 in 5-year increments. Mm-hmm. And so that was the focus on pathways. There was to be able to define pathways that resulted in certain targeted GHG emission reductions at every 5-year period. Okay, and right now I know, for example, that they have been successful in meeting their targets, their budgets for 2010 and 2015. They're now concerned about 2020, but they're doing their planning for 2030. Okay, that's the focus of their plan. And so they need to make a decision as to what the target is for 2030. So they're always defining targets that are about 15 years ahead, but always in the context of working with people in Parliament on, if you pursue this pathway, these are the costs, these are the impacts, and so on. So it's a very integrated decision process between essentially the people who are doing the systems methodology mm-hmm. and the parliamentarians who are really the people who have to make the decisions. So I use that as an example because for me this is a very good model that that the rest of the world can really benefit hugely from.
The UK example, that was a great example. So and I really like they're using this kind of rolling horizon.
Right.
But the key thing is that they're kind of dynamic or adapting based on what is realized and what the initial goal is. So kind of they have this dynamic kind of adaptive process. So now you are probably familiar with their decision or the political system, how decisions are made. Do you know why the UK government, they were able to come up with such a process while other countries probably can follow up? However, they probably wouldn't be able to come up with such a procedure on their own.
Well, I think a lot of the credit for the UK model goes back to Tony Blair. Um, in 2005, he chaired the Gleneagles G7 summit, and where the dominant agenda item was climate change. And so he was able to, at that time, to secure agreement from the rest of the G7 colleagues, plus the governments of Brazil, South Africa, China, and India, and the major international institutions like the World Bank and so on. They all signed off on a communique at the end of the Gleneagles Summit saying climate change is real, the developed world has a responsibility to do something about this, and so on. So right after that, he then arranged for Lord Nicholas Stern, who was then the chief economist at the World Bank, to come back and do a special study on the economics of climate change for the whole world, not just the UK. And so he produced this famous report, which was, I think, was produced at the end of 2007. And then with all of this momentum, they were able to get all-party support in the UK Parliament to move quickly in terms of implementing a Climate Change Act, okay? So I would say it was dominantly very, very strong and sustained political leadership that they had there. And it has withstood the test of time, you know, so even with changes in government.
Now we can dive a little bit kind of into the details because you have been trying to either in your consulting project or some, you know, of course you played a lot of leadership roles, but I think you've been trying to derive what you call this kind of either minimum cost or kind of optimal solutions for, you know, all of Canada, like kind of especially when you accumulate all the efforts towards the target of 2050. So I want us to dig a little bit into the details. What kind of methods and models did you use, and how also did you use the outcome of these models to convince the different stakeholders to adopt the optimal solution that you have come up with? There are two questions. One, how did you derive, you know, those optimal solutions? And two, how did you get those optimal solutions, which you believe are correct, to be adopted by the champions?
Right. So, first of all, the methodology, question of methodology. So the approach that I was asked to define the approach for doing this particular project. The project itself was funded by a family foundation. It was not funded by government or by business. Okay, and I felt that the important thing, because this had never been done in Canada before, you know, where we actually said, so what does a minimum cost solution look like for GHG mitigation? So we decided to use two models. One was an optimization model, which is the Times-Markel formulation, which is really is the global standard for this type of work. Yeah, and it's being used in 70 different countries around the world. There's 5 versions of it in the US, and at least 5 versions. We only had one in Canada, and it had not been applied in a national context, but to me that methodology was important. But the second thing is that I've always, you know, when you're dealing with complex systems and using an optimization model, people are not prepared to just believe the results of the optimization model. Okay, so we needed to complement that with a simulation model where you could actually get into looking at the results in much more detail. So that's what we did. We had 2 complementing models, and as it turned out, there was a lot of synergy between the 2 models. In some cases, we used the output from one model as input to the other model, and vice versa. But we also looked at the overall solution with the Times model, and then in more detail with the simulation model. So So that was the proposed methodology. It's important to remember that the Family Institute that provided the funding, they were not experts in this area. So they had appointed two separate organizations to act as sponsors for the project. You know, this is like being the intellectual backdrop. And that included the Canadian Academy of Engineering, you know, which is one of the three academies in Canada, and another, you know, which is very engineering, very technical, very fact-based, very analytically rigorous, and so on. And then the other organization was the David Suzuki Foundation, which is a well-known environmental organization. Okay, so when I proposed this approach and methodology, I wanted to be absolutely certain that when we produced the results, that there would not be any interception of this in the context of certain ideologies that said, well, we can't accept that because it doesn't match our ideology. So I spent some time with the David Suzuki Foundation, which was, they had taken positions that they didn't like large-scale hydro and they didn't like nuclear, and there were a lot of things about the economy that they didn't like and so on. So I decided, well, I'm not going to go through this unless I have their full support, okay? And so I spent a day with the David Suzuki Foundation and asked them all the hard questions about if the results, okay? I said, I have no idea what the results are going to look like, but if the results come out with lots of nuclear, are you going to reject it, okay? And that was many hours of discussion, but then they said no. I said, if that's what it says, then we'll accept it, okay? And then the same thing with large-scale hydro, okay, because there was such a, you know, strong aversion to hydro, and they said no, if it says hydro, we'll go along with that, okay? So I came away from that with a feeling that, okay, whatever solutions, whatever results we have, they're prepared to defend that. They may have difficulty defending it because of their ideology and so on. So, and I have to say that at the end, they were true to their word. You know, when we presented the results and we showed that there was nuclear and large-scale hydro and so on, the president of the David Suzuki Foundation said that there is nothing more basic than the results of competent, rigorous analysis, okay? So in our case, some of these results we didn't particularly like, but you can't argue against them, okay, if it's all done in a very rigorous way. So that was part of that whole process of, you know, first of all, getting the sponsors to agree that we would go with the results. That was one backdrop. The second backdrop, which is important here, is that since this was the first time that any analysis like this had been done in Canada, I felt it was very important that we began with what I call the no constraints assumption, okay? So we said we have to deal with the fact that Canada has 10 provinces and 3 territories, okay? I mean, that's in the Constitution. But we felt it was important that we not impose any constraints, no political constraints, no environmental constraints, no interjurisdictional constraints. We just said let the models produce the best possible solution, okay? Because later on, when we get into more detailed work, certain jurisdictions are going to say, well, if Ontario is carrying 30% of the cost and we're carrying 50%, that's not fair, okay? So there are going to be other constraints coming into the process later. But it was very important that since this was the beginning, that we start off with a no constraints perspective, okay? And that's been accepted. You know, this is a good starting point, okay?
That was really a very good reflection of, I think, one phrase you used earlier, kind of scientific-based solution and approach. Right. So, you know, kind of such that even, you know, different stakeholders, they might have different political agenda. Right. However, you as an expert, you as a scientist, what you presented to them, it's kind of based, to your best knowledge. That's what the best that the science can tell us.
Yes.
Right. I think. Yeah.
So it was all based on this is the resource potential. Okay.
Mm-hmm.
Yeah.
When you look at this kind of pathway, of course, you said that you use Times Markel to do this, for this analysis. I know like Times is kind of more dynamic model that's probably best suited for this kind of pathway,
Right.
Pathway study. So with this, because you are looking into 2050, right? So between now and 2050, and using this model, how did you manage to consider uncertainty, or even now some people are talking about deep uncertainty? So how did you take that uncertainty element in not necessarily your model, however, like your solution, your conclusion?
First of all, the Times Markel model is a deterministic model. So the only way you can deal with uncertainty in the longer term is to do sensitivity analysis. Okay, and we did a little bit of that, but not. I mean, we didn't have an infinite budget, so we did as much as we could. But the main thing was to make sure that the information we were putting into the model was as accurate as possible, and so on. So before we ran the models, we prepared 14 working papers that looked at each sector. The transportation sector. We broke the transportation sector down into all of its various components, and we looked at all of the various technologies in each of the subsectors, like small cars, medium cars, big cars, trucks, light-duty vehicles, and so on, and then heavy freight transport and rail transport, and so on. So we then looked at all of the technology options. We tried to use the best available information that was available. From various sources. We don't have a kind of a single source, but we had our simulation model had been calibrated against data in Canada from Statistics Canada over a 40-year period, and so we had a lot of the performance relationships defined in that. But in terms of data, in terms of costs, and both investment costs, and then both fixed and variable operating costs, and so on. So there's a lot of work required to make sure that all of the data was as accurate and credible as possible. And so every one of the working papers was reviewed by an expert review panel, and so we did all of that. So we spent about 9 months before we actually did any runs, okay? Just doing that. Now, when we did when we got the results, obviously, we wanted to be certain that we were capturing any sensitivities results, such as, with linear programming, you can have a small change in a cost parameter and then a wild swing in the solution mix, and so on. So we tried to make sure that when we were going through the results and looking at it in detail and so on, that we understood those variabilities and so on. In terms of kind of doing anything stochastic, we didn't do that, so, it was just deterministic. And then we tried to, in selected cases, to do some analysis on what we felt were sensitive cost parameters.
Based on this modeling, and you came up with this strategic suggestion for this pathway, right? And as you said, pathway, strategy, and then policy, right? So because for you are essentially, because you are not representing any interest group.
No.
You are essentially a social planner, right? You're running this model. You provide this kind of the best social optimal solution to this, and for this between now and 2050.
Correct.
Right. So which is about like around 30 years.
Right.
And then when you talk to stakeholders, which might be either CEOs of industry or governors or other officials.
Right.
When you try to communicate this to them, because these people, their terms, 4 years or 5 years. Like for a CEO, the CEO might care about,
Yes, longer term.
So, and also the governor or something, or like even for example, the prime minister, 4 years or 5 years. So which means that, this long-term optimal might not be the optimal for their short-term horizon.
Right.
Right. So this way, did you come across any difficulty in convincing them to adopt this kind of long-term oriented strategy, and then they agree with you and then implement some policy?
Well, we're very early in the process on this. Okay, we produced our report in 2016. This was in some ways, it was being viewed as an interesting report. It was not for government. It was not for business. It was for general public consumption and so on. So since then, we have been advancing the agenda through organizing forums. Okay. For example, in Alberta, we had a forum where we brought in, we called it 50 of the brightest and the best, okay, from government, from industry, from research institutes, from universities, for a full day workshop on how do we move forward, what are the options. So we presented the results of what we had done, and then we talked about, provided some perspectives on options that we hadn't included and that we'd become aware of during the course of the study and so on. So, and then we wrote up the workshop and we sent that to government, and then we said, we should really move forward now with doing some more specific detailed planning for your jurisdiction. So we did that in Alberta, but they wanted to hold off until they had time to give this more consideration. Okay, so it's been a little frustrating that the pickup hasn't happened more quickly. The most recent work that we have done, we actually did a study for the Environmental Commissioner of Ontario, okay, looking at pathways, and that is now a public document for the Government of Ontario, and it has now created a lot of interest in the business community and at the political level. But that document only became public 2 weeks ago. So,
I see.
But we've already had a lot of feedback, okay? And so people are now interested. And most of the interest is they're trying to understand, what we did, okay? Even though we think we wrote it up very well. People like to read this stuff fast, and then they don't necessarily understand it, and so on. So that's ongoing now in Ontario, and we think there'll be an opportunity now to move that agenda forward. There's been a parallel study underway in Quebec, okay? Again, in this case for the government of Quebec, but in that case for the Ministry of Environment, as distinct to the Environmental Commissioner. And so they're showing the results there, and that's there's a lot of interest. It's still being held quite closely at the political level, okay? But Dr. Kathleen Vaillancourt, who does all the modeling with the Times Markel model, she worked on both the Ontario study and the Quebec study. So, we sort of keep close contact with, what do these results mean and so on. So there are similar observations that are coming out. For example, the cost of electricity supply in Quebec is much lower than it is in Ontario. Okay, and so the challenge Ontario has is, does it now enter into full-scale discussions with the government of Quebec with regard to electricity supply? But Quebec is also looking at the New England and New York markets. Okay, so because there's obviously huge complementarity between the hydro potential in Quebec and the existing heavy thermal component of the supply system in New England and New York. Okay?
Yeah.
So those are the kind of dynamics that are ongoing now.
I think it sounds like kind of, even though, as you mentioned, you're probably a little bit frustrated. However, it sounds like there are some very good signs.
Oh no, there are.
That's very good.
No, and this takes time. Yeah.
Yeah, absolutely. Because I remember reading a book. Of course, when we work on engineering, when you design things, you can probably go fast. However, when you come to the point of dealing with people,
Right.
sometimes slower is faster.
Right.
Right.
Yeah.
Yeah. So I think we're running out of time. However, looking again, at what you have achieved, kind of when you started, you said you started as a civil engineer, but now looking back, what would you say to our systems graduate students? Either professional degree, master of engineering student, or to our system Ph.D. student. What would you say to them?
Well, I think the value of a multidiscipline degree, which in many ways is what you are talking about here, has huge value and becomes more important as time goes on. In terms of how do they look at the mix of educational development that becomes part of that process, I think the key areas, they really have to have a very solid grounding in economics, in engineering, and in environmental science. Okay, I mean these are, and it needs to be more than just a kind of one course. It needs to be in depth, and then there's a whole. The whole process of managing interaction is incredibly important, So it's not just what you know, but it's the social skills, to be able to, impart knowledge in a very clear way, but also to be a very good listener. Because the people who make progress in this area are the ones who really reach out to really try to understand the other person's point of view. And so I always think of systems methodology as being two things. One is the methodology itself, but the other is the whole business of managing multidisciplinary processes.
I think even, think back about the UK example you gave, right? I think it's really kind of business of the managing all these different processes and different stakeholders.
Right.
So that is not just limited to, for example, Markel or Times or any model, right? That has very little to do with the models.
That's right.
Yeah.
Yeah. No, it's you have to be well liked. You have to be well respected. You have to deserve to your own personal development that heads you in that direction.
So that's probably even, I think, more fundamental than taking 1 or 2 methodological courses.
Well, you need both.
Yes.
Yeah, you need balance.
Yeah.
Yeah.
Thank you again.
Okay.
Yeah, I really enjoyed it.
Yeah,
I think
well,
this is great. Yeah.
Yeah. Well, my pleasure.